Welcome to this webinar, Mobilizing the Circular Economy for Energy-Intensive Materials, Faster Transition to Fossil-Free, Energy-Efficient and Independent Industrial Production. I am Nicola Bock, Head of Event at Agora Energiewende and your host today. Now, why this webinar? We'd like to present the results of a study that Agora Industry commissioned to Material Economics, a management consultancy firm, sometime last year, if I'm right. And today we are going to publish the executive summary of this study, with the full study following beginning of next week. And this webinar is sort of the first public presentation of the results of the study. And we are very, very happy to be able to do that. The course of the webinar will be like this. After my short introduction, there will be an introduction from Agora Energiewende. Then we will have a first session with two presentations, one by Agora Industry, the sub-brand of Agora Energiewende that conducted this study, and then a presentation by Material Economics, our partner in this project. After that, there will be a session with two comments from representatives from the European Commission and the European Parliament. And then we have foreseen a Q&A session with the audience. Now that's session one, and we should be finished by around 10 o'clock. For the second session, we have invited several representatives from the industry, and we will have a roundtable discussion with 5 of them. And that will be finished with a short conclusion. And then we are around 11 and we let you out for the rest of the day. And without further ado, I would like to introduce my dear colleague, Matthias Buck, who is Director Europe of Agora Energiewende. In the program, you've probably seen Frank Peter, who's Director Industry, but unfortunately, since we had to move the event from last week to this week, he was not able to do the introduction and conclusion anymore. But with Matthias, we're obviously more than happy to have a very knowledgeable colleague of ours also. And Matthias, if you are, there you go. I've seen you just switch on the camera. I hand over the microphone to you and look forward to interesting presentations and discussions, and see you later.
So thank you, Nicola, and good morning to everyone. We live in extraordinary times. Every morning you wake up, you're checking the news of where things are in Ukraine. Now, as Nicola said, the work Agora Energiewende and Agora Industry has been doing on greening industry and the transition to climate neutral industry is now increasingly also focusing on the circular economy aspects. Initially, the work when we started it more than 3 years ago was primarily looking at the greening of primary production of the main energy intensive sectors, so chemical, steel, cement. And now, given the need to look at the full picture, we started to also look at the circular economy aspects, also in view of what the Commission has been preparing for some time, the Circular Economy Action Plan and related legislation. Now, when starting that work, of course, supported by Material Economics, we could not know about the current terrible situation, but of course, the Russia's war of aggression really puts a spotlight on the deep dependency of Europe when it comes to fossil fuels, and creates a situation of urgency of identifying levers to reduce our dependency as fast as possible and to regain our sovereignty when it comes to taking our fate into our hands. Now, from that perspective, I think today's webinar and the report that is published, the executive summary, and then next week the full report, really should help to give a good steer now to the final work on the Circular Economy Action Plan, and to really pull all levers to be certain that we are reducing our dependency on fossil fuels as much as possible, also through this part of what's going on in European legislation. We have a completely packed program today. It's very dense, a lot of colleagues contributing. I will not say much more because Nicola, you already introduced the program as such. So I just wish everyone a very, very successful webinar. May it be a very productive discussion and that we all leave this webinar today with very concrete ideas on how we can make a contribution to regaining our sovereignty when it comes to energy in Europe. So Nelly, over to you. I will not say much more.
Good morning, all. Thank you, Matthias. Good morning, all. A warm welcome from the Circular Economy and Industry Project team. Can you hear me now?
Yes, we can hear you, Nelly.
Thank you. So, a warm welcome from the Circular Economy and Industry Project team at Agora, with Oliver Sato, Senior Advisor, who led the study, Helen Bursmeister, Project Officer, Camilla Oliveira, Project Manager, and Guido Whittaker, Project Manager as well. And not to forget Paul Minnick, Project Manager, who contributed to the study, but who will be kindly supporting with Q&A today.
Sorry, Nelly, can you switch on your camera, I think?
I have.
It's not switched on.
Sorry, here we go.
There you go.
Hello, that's why. Okay, sorry about that. So to start off this first session, we will present our study's findings. What can circular economy deliver for the energy-intensive industry? A lot, as we will see. So in this project, we focused on steel, aluminium, plastics, and cement and concrete, and related key value chains, mobility, plastic packaging, and buildings. We are going to walk you through the context and potentials from the circular economy for energy-intensive products and value chains, give highlights for each product and value chain with Guido, Camilla, and Helen, and share our conclusions and policy recommendations with Oliver. Could I please have the second slide, Oliver? Thank you. So policy-wise, what are we doing today to take industry to climate neutrality in Europe? We tend to focus on new methods for virgin material production, leaving aside secondary routes. We put our efforts on new clean technologies, clean hydrogen, carbon capture and storage, and supporting instruments like CCFDs, carbon contract for differences, and funding instruments for the new infrastructure development, such as the Innovation Fund from the EU Trading Scheme. And as the EU ETS innovation funding shows, as yet very few projects include secondary routes. All this is necessary, of course, but focusing solely on primary production routes is highly inefficient in terms of both energy use and the use of resources. It would require a massive build of new infrastructure for renewable power, green hydrogen, capture, transport, and storage of carbon, and comes with risks on increasing carbon costs and dependencies on foreign supply. You can see from the graph, power needs for steel, cement, and chemicals production by 2050, with a clean primary production and low circularity scenario, power need is huge, over 1,400 terawatt-hour per year. With a high circularity scenario, needs are still very important at 1,000 terawatt-hour a year, with a saving of 400 terawatt-hour a year. To put this into perspective, it is a saving greater than today's consumption by those sectors at 353 terawatt-hour a year. Note that it took the EU 15 years to build capacity to get over 500 terawatt-hour of renewable electricity production per year, as you can see from the column on the right in the graph. So this represents an important cost reduction for energy-intensive industry to go green and remain competitive. Let's now look at the need for carbon capture and storage for the cement and concrete sectors. As you can see, cement production sites are scattered all over Europe. Over-relying on CCS has limitations in terms of the availability of suitable sites, the infrastructure costs, public acceptance, of course. Some will still be needed, however, together with storage of biocarbon to create negative emissions, but circularity of both CO2 and materials and material efficiency will be required to achieve net zero targets and for the sector to remain cost competitive. So now let's take a closer look at how applying enhanced circularity greatly reduces energy consumption, emissions, and costs across the products. Here you can see the carbon intensity for all energy-intensive products that are much lower, with a factor of 45 for aluminum, the most carbon intensive with the primary route, 5 to 6 for steel and plastics, and over 2 for cement. And what's more, on plastics alone, 149 million barrels of oil equivalent and up to 2.7 billion cubic meters of natural gas could be saved annually by 2030. The EU has abundant and growing scrap and waste in the energy-intensive sectors to source from, with high-quality closed loops to save a lot of energy and reduce emissions. On the graph, you can see the example for steel. The amount of available scrap today is 2/3 of the primary steel production. While steel needs are expected to be stable up to 2050, the amount of available scrap is expected to reach the same level as primary production, as you can see in the graph. So by 2050, a high-quality closed loop would be highly resources efficient. So what the EU is currently doing on circularity. The EU Circular Economy Action Plan, adopted in 2018, launched new pieces of legislation contributing positively to the goal of the circular economy, with a waste package targeting municipal solid waste, the Packaging and Packaging Waste Directive, the amendments to the Landfill Directive, the Single-Use Plastics Directive, and the strongest measures were on single-use plastic waste and certain types of plastics packaging, such as recycling quotas for PET bottles. However, from an energy use and emissions perspective, it is important to also target steel, aluminum, cement, and concrete, in addition to plastics, and together with the 3 key related value chains using those products: vehicles, the full set of plastics packaging products, and construction and buildings. All those account for 60% of emissions when considering these 4 materials, as you can see from the graph. And altogether, the sectors account for 581 megaton of CO2 equivalent annually today, or 70% of all industry emissions. So in addition to the lack of focus on energy-intensive products, our current recycling practices can be improved substantially. There are untapped potentials for energy savings and emission reductions as we tend to downcycle. That is, for a lower ranking usage of the material rather than truly recycle for the same level of usage. We tend to focus on quantity over quality for recycling targets, which leaves aside contamination issues such as copper accumulation in steel. We overestimate a current recycling performance for plastics to 35% when it is less than half, and this pair will go deep into it later. Statistics on the end of life of plastics miss out on misallocated waste, and mixed waste streams due to poor collection, incineration, landfilling, exports, and recycling losses. We also pay hardly any attention to material efficiency. New scrap is often considered as recycled material when such waste should be minimal and disincentivized, and the focus rather on post-consumer scrap with high-quality recycling, for instance, still in the vehicle value chain. So all in all, the potentials for energy savings, emissions reductions, and cost reductions are very large for these products and value chains, already within this decade and even larger by 2050. Material circularity and efficiency should be an integral part of a comprehensive industrial decarbonization strategy. It has the potential to deliver for steel, aluminum, cement, and plastics materials and products. As you can see from this graph, an emission reductions of 70 megaton per year by 2030 and 239 megaton per year by 2050, which is the equivalent of 10% and 34% of the total emissions from industry in the EU, respectively. It can also deliver lower new infrastructure costs by euro 1.5 billion per year, significant electricity savings, as we've seen earlier, of 400 terawatt-hour annually by 2050, and fossil fuel savings. Let's look now closer at these potentials per product and value chains, starting with steel and aluminium. I hand over to Guido.
Thank you, Nelly. As Nelly has shown in one of the previous slides, in the EU, we have increasing steel scrap. The same is true for aluminum in the future. I will focus now on the example of steel. With this larger amount of scrap that will become available in the future, scrap-based steelmaking in the EU can increase significantly, which brings a lot of advantages. Some of them we have heard already, but only if copper contamination levels in scrap are addressed. What you can see here on the left-hand side are the copper tolerances of different steel products. And what you see is that with the current copper contamination level in OECD scrap, there's only one product that could be made out of the steel scrap, which is rebar. That is a steel product that is used in construction. For all other steel products, and again, we're talking about the average, this would not be possible. That's why it is very, very important if secondary steel or scrap-based steel making is supposed to substitute primary steel, that we maintain clean scrap flows for steel, and that we get away from this practice today of downcycling. What can we do to address this? Measures could be advanced copper separation technologies, that if steel scrap is already contaminated with copper, you get the copper out. But you can also do stuff before that actually happened, which is to eliminate adverse recycling and sorting practices, where you keep the waste streams separate in the first place. Another really important aspect is to look at competitiveness. Scrap is an EU domestic resource, and a higher share of scrap-based steel production will increase the resilience, the energy efficiency, and the resource efficiency, and therefore ultimately the competitiveness of the EU steel industry. The more clean scrap we have, the less virgin primary steel we need, the less green hydrogen, for example, we would need in the future. By 2050, our study finds that 35 million tons of virgin steel production, equivalent to 63 million tons of CO2 emissions, could be replaced with secondary steel if copper issues are addressed. And I hand over to Camilla.
Thank you, Guido. In a higher circularity scenario for plastics, we assume that waste plastic will be a valuable resource. This means that waste plastic will be demanded as a feedstock for plastic production. And this vision results in less CO2 emission, in less plastic pollution, and in less imports of virgin feedstocks. And what are the CO2 reduction potentials, the solutions, and the conditions for this high circularity scenario? First of all, reduce plastic production, and by avoiding unnecessary plastics, for example, single-use plastics. Also, reuse plastic whenever possible by investing in innovative business models, raising awareness of consumers. Another solution is to increase the rates of mechanical recycling from today's around 11% to 35% by 2050. And this has the potential to reduce 27 megatons of CO2 by 2050. The conditions for that is to improve collection rates and the sorting of plastic waste, For those plastics that cannot be mechanical recycling, chemical recycling will have a role. We assume that by 2050, there's a share of 40% of chemical recycling, and this can abate 44 megatons of CO2 by 2050. The conditions for that is to ensure a high degree of efficiency of the chemical recycling technologies, avoiding losses, and ensure that the electricity will be sourced by renewables. And finally, for those plastics that cannot be recycled, waste incineration will still have a role, but of course, much less important than today. Today is around 55%, and we assume a rate of 25% by 2050. And the priority for incineration should be for bio-based plastics to ensure net zero emissions in waste incinerations. That's it for plastics. Now I hand over to Helen.
Thank you, Camilla. So as Nelly has already mentioned in the introduction, there is a strong focus on carbon capture and storage as a primary decarbonisation option for the cement and concrete sector. However, solely focusing on CCS for cement and concrete neglects the huge potential that is offered by circular and material efficiency approaches. A number of those are currently in development, including using recycled inputs for new cement production, recarbonation, but also the optimization of cement and concrete formulas. Alternative binder approaches alone could lead to emission reductions in the sector in the order of up to 31 million tons of CO2 by 2050, constituting a 30% CO2 reduction versus the business as usual scenario. With regards to cement recycling, this could lead to additional emission reductions in the order of up to 16 to 24 million tons of CO2 per year by 2050. There are, however, a few obstacles to the use of these innovative alternative production routes. First, there are the standards that prevent the use of these circular economy and material efficiency approaches, but also the current EU ETS design disadvantages circular economy strategies in cement by giving out free allocations to both conventional and low carbon primary production. This situation leads to the result that we see in the graphic on the left-hand side, namely that cement at its end of life is mostly used at low value as an aggregate in construction work. For example, as a backfill. And with that, I hand over to Oliver.
Thank you, Helen. So the other pillar of the strategy that we outline in our report is that in addition to enhancing recycling and reuse of materials, so the circularity aspect, we can also be more efficient in the use of these CO2 intensive materials. And in some cases where appropriate, we can substitute them for other materials where we don't have other options. Now, greater material efficiency and substitution is possible in the building sector, in the vehicle sector, and in the packaging sector to some extent. There are a range of potentials here. In buildings, for example, one can optimize the design of materials to reduce the embedded carbon and material intensity of certain components. It's possible to optimize, as Helen said, concrete formulas, but also to use the right concrete for the right application so that you minimize the total CO2 intensity of the concrete for a given structural performance. Prefabricated components can also help to reduce labor costs, to make it simpler to achieve material efficiency through economies of scale. Material substitution is appropriate, obviously, in certain applications. We know a lot about wood or other materials that can replace concrete in some cases. And we can also try to prolong lifetime. So, for example, Actually, China's a good example of this. It's not in the EU, but the average building life in China is apparently something like 25 years, whereas in the rest of the OECD, it's closer to 60 to 70 years. In the vehicle sector, we also have options as well. One can optimize the design also to reduce embedded carbon. One can try to create incentives to reduce the size and weight of vehicles beyond what's already encouraged by CO2 standards. There's some possibility also for material substitution and for prolonging the lifetimes of certain components. In the plastic packaging sector, we can limit excess packaging. We can try to shift to reusable product formats. And in some cases, as Camilla was suggesting, we could substitute to alternative fibers for certain applications. In total, when we look across the board, if you sum up many of these different potentials, we think up to 29 megatons of savings will be possible of CO2 by 2030 with ambitious policies implemented now, and up to 49 megatons by 2050. There are some key challenges. So one of the main challenges is that we really lack strong incentives at the conception phase of either products or construction projects where the biggest potential exists. So this is what the graphic on the left suggests, which is the earlier on in the production value chain you create the incentives, the greater the potential to design for greater material and CO2 efficiency. As Helen mentioned, a lack of carbon cost pass-through from the ETS also lowers the cost of virgin materials, making them less expensive to use and therefore less incentive for efficiency. In some cases, higher costs of labour or logistics can be a barrier. And so one might want to think about regulatory approaches that can help to overcome those. And there's technological immaturity and skills problems in some cases as well. So what can we do, taking all of the potentials that we've discussed, what can we do in the EU circular economy legislation and the Green Deal to start to unlock these potentials? We think that we need to focus on sort of have a two-pronged approach, one that focuses on the demand side and one that focuses on the supply side. We're good economists at Agora. Why is the demand side so important? Well, because at the moment, there's a sort of chicken or egg problem where there's a lack of supply of high quality materials because we have this sort of downcycling problem. And because there's a lack of supply, there's also that induces a lack of demand, and the lack of demand then reinforces that lack of supply. So you can sort of see this phenomenon to some extent in the graphic on the left-hand side, where you see this very high demand for plastics, very high plastic waste collected, but actually very, very low amounts ultimately going to recycling. And then the demand for recycled plastics, at least as of 2019, remained even a small fraction of the actual waste available from recycling, right? So what are some of the levers that we can pull to create demand? Well, we think that as one of the keystone policies is recycled content quotas. We think that the evidence from PET bottles regulations that the EU has already introduced illustrates how effective such policies can be. They basically help to force by creating a regulated demand effectively, they basically force the sectors not just to buy recycled plastics, but to coordinate with the value chains to fix the various problems along those value chains to start to put in place the supply. So we think recycled content quotas are critical as a kick-starting measure, not as a magic bullet, but as a kick-start measure. The second thing we need to do, and this is relevant also to include material efficiency and a broader range of incentives for substitution as well, is to put limits on embedded carbon in final products. So we can think about, for example, putting a limit on the embedded carbon per metre squared in the building, or similar policies for vehicles and packaging, as a way to basically incentivize these consumer-facing end of value chain products to find the most efficient way to reduce emissions, and that in some cases will mean enhanced incentives for recycling, material efficiency and substitution. There are other relevant policies here too. Integrating circularity into the way we label low CO2 products and create legal market tools is very important, as also, as is mentioned, is the current incentives created by the European Emissions Trading Scheme. But demand is not enough. So we can see actually from the left-hand side, this graph shows indeed the example of PET bottles and the the prices basically per tonne of PET that were induced by the EU's regulations kicking in from 2019. And what we see is that actually the price of virgin plastic declined somewhat, the price of recycled plastic increased a lot, which is in a way good because it demonstrates there was higher demand and there was therefore an economic justification to invest in enhanced recycling and collection technologies. But there are also limits to this. So one needs to be careful about creating a demand that actually can't be met due to lack of supply. And so we therefore need to focus in parallel on supply side solutions. There are many policies that could be relevant here. Advanced recycling technologies, so for example, enhanced copper separation techniques for steel, improved separation of different aluminium alloys can also be very, very important as well in the case of aluminium. We can require best available collection and recycling techniques. So some countries, for example, are already using technologies that resort mixed waste to extract the plastics that would otherwise be lost, that are not separately collected. And up to 75% of these plastics can in principle be recycled. We can think about reforming extended producer responsibility schemes to incentivize more closed loop recycling, because currently they tend to lead to a large amount of recycling that's actually downcycling. We need to address outdated product standards. So Kuz will likely talk about this in the context of the cement sector. We need, as Camilla said, a robust sustainability criteria when it comes to chemical recycling to make sure we're not increasing energy use or emissions on balance. And we need to strengthen limits on exports and landfill, especially if we're to include incineration in the ETS to not create perverse incentives. So, as a summary, we think that the circular economy is extremely important to meeting our CO2 goals in Europe. It's also critical to meeting our goals to reduce fossil fuel consumption, including of gas and oil. And we think that what's missing at the moment is an integrated strategy to combine our CO2 policy for industry with the circular economy. We'll stop there. And I'll hand back to Nelly.
Thank you, Oliver. Thank you very much. So after this detailed overview for energy-intensive industry, we are now going to have a deep dive on end-of-life plastics with Per Cleves, partner at Material Economics. Per Cleves has supported us with our study on data, modeling, brainstorming, and review. Thank you, Per, for the great support we received. So Per is economist by training and has been working internationally on resource and climate issues since the early 2000s. Per will enlighten us on the issue of missing plastics in the EU. Per, over to you.
Good morning, everyone. I hope you can see and hear me okay. We will go from this very big overview of a tremendous number of topics to a bit of a deep dive on one topic that has been, I suppose, bothering us for a while. And that is that I think when we start talking about plastics and its role in a future circular and low carbon economy, we often overlook the carbon that's in the plastics. We talk about their production that's regulated by the EU emissions trading scheme. The first initiatives to address those emissions are starting to gather a bit of ground. But we don't often talk about the carbon in the plastics if it comes from a CO2 perspective. At the same time, we talk about plastic waste as being a big policy topic for all the reasons that I'm sure everyone is familiar with in this discussion. But when we have looked at this for the last several years, we have been puzzled by the estimates of how much end-of-life plastics there are. And this, to the extent that this is a major policy priority and important to our climate targets, it seems like the first thing we need to know is how much end-of-life plastics actually are. And so with support from Agora, we now finally did a deep dive on plastics, looking at the data in the same way that we would look at other major commodities such as steel or aluminium, and presenting some new estimates on how much plastic waste we think there is in the Europe. And when I say Europe in this presentation, I mean the EU and UK, Switzerland, and Norway. In summary, what we find, if I can make my presentation work, is that Europe generates about 45 million tons of plastic waste per year. And this is quite surprising because normally we talk about there being 30 million tons of plastic waste. Of course, if there is 50% more plastic waste than we typically are accustomed to, that has quite big implications for how far we have got with recycling. We think that the recycling rate that's most relevant to talk about is how much recycled material we produce relative to how much plastic waste that there is, or end-of-life plastic there is, and then we end up with a number of around 15%, which tells us something about how effective the current policy incentives and regimes are. Also tells us that we have a long way to go to achieving the high numbers of circularity needed if we are going to meet climate targets and create a more circular economy. We then deep dive also on the topic of current CO2 emissions. It isn't entirely known exactly how much plastic we incinerate, but when we look at this, we estimate that this gives rise to about 70 million tons of CO2 emissions today. But of course, some of that plastic is used instead of other fossil fuels, so the net effect is a little bit more than half of that. But the key perhaps takeaway from all of this is that this becomes increasingly urgent as we look ahead. We can't say that plastics replace other fossil fuels in the future when all fossil fuels need to be phased out for a net zero target. We want to stop landfilling plastics, which will drive more plastics either towards circularity or towards incineration. And for a number of other reasons, we see these emissions increasing very fast, the net emissions increasing very fast. I will take you through some of the details of this. I'll have to do it quite fast. A report will be available to explain why we come to this perhaps somewhat surprising conclusion. The first thing to note is just to say, our starting point is the plastics we use. Because to date, we have seen plastics, end-of-life plastics, most as waste rather than as a materials flow. And whereas we wouldn't actually dream of, I think, to estimating how much aluminium is recycled or how much scrap there is, etc., by trying to count bits of aluminium that reach end of life, we would instead look at how much aluminium do we put into the economy and what then happens to it. And for plastics, what we put into the economy is roughly what you see here. We saw a period of enormous growth to around the 1990s or 2000, but for the last 20 years, a fairly flat profile for plastics use. And if you reflect on this and put it in relation to the number we have been accustomed to, of 30 million tons of end-of-life plastics, the question sort of arises as, where did all these plastics go? Most plastic products are pretty short-lived. There are exceptions, pipes and various bits of buildings and so on, but most of them are returned to the economy well within 20 years. And if so, if we've been using more in the order of 45 to 50 million tons of plastics for the last couple of decades, then it becomes difficult to see how that's consistent with there being just 30 million tons of plastic waste. So this is what we've wondered about for a long time, and we decided to construct a very elaborate material flow model for plastics, where we track all the end users and the various polymers in something like 50 categories over time. Then put that against the standard approach of saying what's the lifetime of these different products. And that's when we end up with an estimate that I will deep dive into in a minute. I should say also that, of course, one needs to account for recycling. What I showed you was just the new virgin plastics sent to converters in the EU. And you need to account for trade. We export vehicles, we export end-of-life electronics, we import a lot of packaged goods, use the best data we could on that in order to derive the estimates. Here is our headline result. Again, it's around 45 million tons of end-of-life plastics. We've seen that it continues to grow because driven in part by past growth in plastics use and partly by some increase in the present. A lot of it is packaging, consistent with what we've known for a long while, but also that there's quite a lot of end-of-life flows from other categories. The one that's small relative to how much plastics we use for it is buildings and construction, where there's a lot of long-lived products. But otherwise, we see a pretty consistent use with the sort of pattern of plastics use, overweight in packaging. So the question is then, what happens to these 45 million tons? One way to think about it is the following, right? 45 to the left, the 15 million tons of missing plastics that we haven't really got any sort of established numbers for what happens to them. The 30 million tons that you get if you do sort of try to count plastics bottom up from waste statistics, and then the split in landfill and energy recovery. We know pretty well also how much is sent to recycling. It's sort of much like the data we use for this study is sort of recorded in the normal course of business, so we can have a good handle on that. We know pretty much how much is lost in the recycling process. And so what we end up with is something like 7 million tons of plastics produced from European end-of-life plastics, some of it in Europe, some of it exported, more on that in a minute. And from that's why we think that the recycling rate here that we should be focusing on is 15%. That tells us something about how efficient our current system is in turning the end-of-life web flows into useful products that could replace virgin plastics, and with environmental and other economic benefits that has. We have been used to, mostly for sort of administrative reasons, and we are changing that too, of course, talking more about 35% recycling. And we think that that comes from both the effect of underestimating how much end-of-life plastics there are, but also in not talking about the efficiency of the recycling process. If that's the case, then this is the type of picture. And here we go on to slightly thinner ice. We're having to use new data that we've generated to then try and figure out what that new data might imply for the important question of how much is landfill, how much is incinerated and recycled. Again, I think the recycling is pretty well known. The split between incineration and energy recovery isn't all that well known. We use the same split as in existing estimates, and then we end up with what you see here, around 24 million tons of incinerated plastics and 14 that are landfill. And that the European Environment Agency says something similar, in saying that 20 to 30 million tons of plastics are burnt each year. So we may not be too far off here. And what this means is, in CO2 terms, you can think of these 45 million tons of end-of-life plastics. If you weight it by all the different polymers, you'll find that every ton of it has enough carbon in it to produce around 2.8 tons of CO2 if it is burnt. Of course, a lot of plastics aren't burnt. Whatever we recycle, the carbon is put to good use again. When it's landfill, the carbon is stored. Whatever the other disadvantages of landfilling, that is, it certainly can be seen as a sort of carbon storage in this particular case. But then we have the proportion that is incinerated, and again, that is around just under 70 million tons. If with the split that we have used here, we did a detailed estimate of what fuels that displaces. It displaces everything from electricity to heat, in cement sectors, in district heating networks, in electricity generation. And when we put all that together, we find that around 30 million tons of emissions are displaced by the use of plastics, leaving a net emissions here of 38 million tons from the incineration. Of course, if we get better data on the exact incineration landfill split, this might move a bit, but it does highlight the order of magnitude of CO2 contribution from end-of-life plastics today. We then did a thought experiment, and I should be very careful to say that this is not in any way a forecast, but if the blue is the current picture I just presented, then I think the type of estimates that we often use to talk about more plastics in the future is an increase of around 30% to 2050 can be debated, and many of the things that Oliver and others talked about could keep that down, but that's what we use for illustration here. If we phase out landfill, as we said we would do, then more would have to go towards incineration and circularity. And here we illustrate what happens if we don't increase our recycling rate, then you get an increase. And then, of course, the net effect is erased as the economy decarbonizes. We're no longer replacing fossil fuels, we're replacing other clean solutions. And you can see that we're sort of starting to approach the same net CO2 emissions north of 100 million tons, a very large post to be concerned about as we think about net zero emissions trajectories. I wanted to show one more slide to say that I don't want to claim that we are the only ones or the first ones to look at this. We haven't seen many of this type of material flow analysis for plastics for Europe, but they're starting to appear. And so we compared with the studies that we could find. And when we adjust for the different scope, the polymers covered and so on, we find actually very similar estimates in the literature. What we did was to try to use the same, construct a new model, our new assumptions, and we landed in a very similar place. So I have quite a lot of confidence in the numbers, that they are roughly right. More work can be done on trade and on other topics, but I don't think that I don't think that this method that we've used here, I don't think that there will be major changes in lifetimes and other things that will fundamentally change it. So that's what I wanted to present here, and perhaps with that, turn over to a discussion about what that means.
Thank you very much, Per. Thank you very much. Just before going over to our speakers, Oliver, there is a question on the scenarios. Could you just highlight us regarding the scenarios used, and then we can move on to our speakers. Thank you.
Sure. So the scenarios are based on a modeling tool that was developed with the aid of material economics. Basically, look, it's a little bit along the lines of what Per was presenting in most cases, which is that we have a sort of a material flow model where we look at how much is being used, how like the average lifespan of what we think the products are, roughly how much therefore end of life materials there are, for example, of plastics or steel, etc. At a certain time, and then we sort of look at the statistics of how much is currently being recycled or incinerated or landfilled in those categories, and then we compare that and basically make a judgment on what are the different potentials for the different solutions that we're describing. So it's a combination basically of sort of top-down statistics and some bottom-up judgments on our part to think about what the potentials would be. I would note that we are assuming that this won't happen on the basis of sort of market forces alone. So what we're assuming is that quite strong policies would be needed to get the potentials that we describe, and our estimates are therefore, I would say, pushing the envelope, especially for 2030, where time is limited. But we want to demonstrate that there are large potentials that can be exploited if policy is gotten right. So that's, I think, the main logic behind our estimates.
Thank you, Oliver. So let's move to our first session. So I invite our speakers, first two speakers, William Neal and Bas Heekhout, on board. William Neal, I cannot still, could you switch your camera on? You're advisor on circular economy and digital environment at the European Commission. You focus on circular economy and green growth, and you're currently focusing on the preparation of Sustainable Products Initiative and Digital Product Passport, the Sustainable Finance Taxonomy, and the circular economy in relation to digital policy, employment policy, and European funding. William has previously served for 11 years as a member of cabinet for several European commissioners, advising on such topics as circular economy and eco-innovation. And I'd like also to welcome Bas Heekhout, member of European Parliament, the ENVI Committee Vice Chair. So Bas has been a member of the European Parliament delegation leader of the Dutch Greens since 2009. He is a member and coordinator of the Committee on the Environment, Public Health and Food Safety, and a substitute member of the Committee on Economic and Monetary Affairs and the Committee on Budgetary Control. He also co-authored the IPCC report on climate change, which received in 2007, as we know, the Nobel Peace Prize. So you're very welcome. I still cannot see William. I hope you're on board.
Yeah.
Yes, thank you. There you go. Thank you very much. So we would like to hear first your reactions to what has been presented, and by the Agora team and by Per as a first reaction to our findings. William, would you like to start?
Yes, thanks, Nelly. I mean, what can I say? I mean, well, congratulations, first of all. I mean, I agree 100%. Well, on the condition that what Per was saying about calling plastic landfilling carbon capture, I'm not so sure about that, but I don't think that was serious. But you've really hit the nail on the head, and definitely a nail made from closed loop recycled steel without any copper contamination. It's well researched, as we would expect from material economics. I'm often quoting their previous reports, and it's very well presented. And it's of course very timely. I mean, we've been reminded again recently of our need to cut our reliance on fossil fuels, especially that which comes from autocratic regimes, but also to be able to do that whilst keeping prices acceptable for consumers, which is a main challenge. I think we miss a massive part of the plot if we fail to address materials and the embodied energy and carbon in them. If you consider that using a building for 20 years, after you've used a building for 20 years, you're only equaling the amount of energy that was put into the materials and processes for actually building it. So we really need to focus there, and we're not doing it. If you look at the recovery and resilience plans of member states, the construction and renovation actions, that they weren't very circular. And we really need to be able to get across how important it is to make those sectors more circular. At the Commission level, I mean, we've been inspired by in the last 10 years by the link between DG Energy and DG Climate, and sort of linking the solution and the problem. We're trying to do that in circularity, linking DG Environment and DG Grow on that. But I think that we're still not really fully recognizing the links that we need to have between circularity and climate. I'm very encouraged by a lot of the conclusions of the report. I mean, because I think we're already doing a lot of it, or about to do a lot of it. There's a long list, so we don't have time to go into it all. But I mean, as Nelly said, in 2018, we had our plastic strategy. We banned a lot of single-use plastic uses. We revised our waste legislation. We're now working on labelling for separate collection. We're about to come up with a revision of the packaging and packaging waste directive, looking again at essential requirements and eco-modulation of extended producer responsibility. We've just tabled a waste shipment regulation review. We're coming up with an end-of-life vehicle directive review, which again can look at things like the copper in those end-of-life vehicles. We're defining our positions on bioplastics and biodegradable plastics. Next month, we have a review of the, and this isn't within the Circular Economy Action Plan, but we have a review of the Industrial Emissions Directive, which is bringing in aspects of circularity. As you said, I'm working on the taxonomy, and there, of course, we have the delegated acts for climate, but we're working also on fixing technical screening criteria for circularity, a substantial contribution to circularity. So there's a lot that we're doing, and we're not doing circularity for circularity's sake. We need to link it to those important impacts on climate and biodiversity. I would say that Circular Economy Action Plan, this one, we've done plastics in the previous one. We're now looking at other high impact value chains. So in next week, we will adopt a strategy on circular textiles. And we will also next week adopt a revision of the construction products regulation. We'll be looking at electronics in the future. I would just say, just to terminate, I mean, the one thing which I think is a little bit missing in the picture here is I think that you're right to shift our focus from sort of efficiency, virgin materials efficiency, to material circularity and efficiency. But what are we using those materials for? We're using them for products and buildings and so on. And we need to focus on the importance of keeping those products and buildings and other assets in use, in function for as long as possible, for prolonging the life, on the principle of what you don't waste, you don't have to replace. And if you don't have to replace it, you don't have to use the materials and energy to produce them. I do have a little problem, and I think I need a bit of convincing on the embodied carbon limits being more impactful than eco-design policies. The other big thing that we're adopting next week is the eco-design for sustainable products regulation, where we're extending eco-design to cover all kinds of products, not just energy-related products, everything from shampoo to furniture potentially. We're bringing in new criteria related not just to energy performance in the use phase, but to circularity, to durability, all of these things, because we estimate that about 80% of a product's lifetime impact is really at that design phase. And Olivia was talking about the conception phase in buildings. It is key. If we can bring in physical requirements on design of products for durability, for recycled content, so as you were saying, we need to push up the demand for recycled plastics and other recyclates. If we can eliminate some of the substances in products which are causing the problems for high quality recycling, then design and eco-design is a really crucial instrument. And I would say we're not just making physical design requirements, we're talking about data requirements, and the digital product passport will now allow us to sort of have that traceability through the whole value chain and enable things like potentially embodied carbon calculations and so on. So I would just make that little adjustment. I think that we really need to look at the use phase of the things that we're using the materials for, but otherwise, really congratulations.
Thank you very much, William. Thank you for this very detailed feedback. I'm sure we will come back on some of the points, and thank you for appreciating our work. Bas, I ask you to come forward to have your reaction from your side. Thank you.
Thank you very much, Nelly, and also thank you, William. Good to see you again. We know each other for quite a while already, working on comparable topics, so it's always good to see each other in a session like this. Now, first of all, I also just have to extend my congratulations and my thankfulness to Agora Energiewende to do this study. Also because I think what is very important is that you are shifting the focus to kind of the intensive industry, the energy intensive industry, and not only how can we clean up our processes to reduce CO2 emissions, which has been the kind of the classical approach to this, but also now really by bringing in circularity into these sectors. And I think that is really crucial. And I think William already very briefly mentioned it, and I understand, but I think this is really one of the key problems and issues and challenges we're still having, is that the world of climate change policy and the world of circular economy is too much divided. And I think you're pushing on that quite rightfully so, and I hope that will help. And then I know William already said it, already when we are talking about circular economy, and we have to be very honest, the European Commission is talking about circular economy already for more than a decade and has been pushing for this. I think until now, circular economy has been a kind of a niche topic. Everyone likes it. Everyone loves circularity, circular economy. I haven't heard one politician that is not saying, oh yes, circular economy, how nice. But it has never really gone into the fundamentals of our energy intensive industry. So it's more looking at the nice little products. We have all kind of examples, you know, textile tiles that are being recycled. I think people that are being active in the circular economy have seen those examples for 10 years and maybe are getting a bit tired of it, because we need to go into a much more fundamental part of it. I think the Commission did quite well the first steps with that on focusing on waste and really redesigning our entire conception, what is waste, and indeed by focusing on plastics until now. But what I really like about this study is that you are broadening it much further to plastic, but to cement, to steel, you know, the real heavy stuff that is energy intensive. And I think here, I think if I can just resonate a couple of points, and of course, I have to say, we just saw all the presentations, so there's a lot of questions that we have as well, right? Because it's so much information that's being thrown at all of us that I sometimes also have questions. And one very simple question, for example, when you, Nelly, were doing your introduction, I was a bit struck by the CO2 gains with enhanced circularity and material efficiency. And there was the biggest potential was in enhanced circularity and not so much in material efficiency. And I was a bit struck by that, and I would raise a question on them because I think there is much more potential also material efficiency. So then, of course, you get into questions, how did you do the modeling and all that? We can't go into these details, but I think this just to show you that there are still questions there. I think what is very important is the point is that until now, policies at the European level have been focusing very much on the supply side. If we want to make a success, we indeed need to address the demand side. William very rightfully so said that, that the Commission will now come with the Sustainable Product Initiative, where eco-design is part of that, which is a long wish of people working in this field, like, please expand the eco-design also to material efficiency, not only energy efficiency. But of course, now the big question is, after listening to this presentation, will the eco-design really go also into the matters of steel and cement, etc., and not only consumer products? I think this is also a very important topic that we need to address in order to make sure that we are really touching upon the demand side. Then my last point, because the time is limited, I'm very well aware, is this link with climate change policies. And I think a couple of you mentioned it also a couple of times, is that this is very much, should be very much linked to ETS, which is the cornerstone of climate policies that we're having, emission trading system. However, in the design of ETS, there is hardly any attention to circularity. And that indeed leads to issues around free allowances, which are totally not based on circularity, but are only based on CO2 emissions and intensity there. But indeed, also, what do we do with the revenues? And I think also you showed that very clearly, Nelly, that if we look at the Innovation Fund, for example, we are not looking at how to improve the use of innovation into circularity. So really bringing those two worlds much closer together, not only by talking, but really into policies, I think is going to be still one of the biggest challenges that we are having ahead of us. So if I would put some little wishes there still on the table, also of William, although I know he has a lot on the table already, I still, of course, use this moment to put some of those wishes here as a first reaction to all that you have represented, and I really want to thank for all that. Thank you.
Thank you very much, Bast. It's also a very detailed answer. So we're very, very pleased to have this feedback from both of you. William, would you like to react further, maybe?
Yes, I mean, I think I agree very much with what Bas has said. I think another area that we need to look at is, I mean, Bas talked about maybe as going a little bit too much along the line of the best practice business models of circularity and how some of them are very innovative. And we definitely do need to mainstream. But if you look at the possibilities of mainstreaming some of those best practices, the potential is huge. I mean, take remanufacturing, for example, instead of actually taking materials back into their fundamental aspect, just by taking whether it's an automotive component or whatever, and cleaning it and replacing the worn parts, you can put a product back on the market which has exactly the same functionality, same warranty, and the UN International Resource Panel has estimated it's usually about 90% reduction in the virgin material and energy use to get that on the market. So 90% cut. I mean, it just shows that some of those top runner models are really worth putting into the mainstream.
Thank you. I would like to pick up a question from the audience from Tamid Chaudhary from CISL, who's asking, are we expecting any future demand side related policy measures coming from the Commission anytime soon? Agora is now answering it. So if Agora is answering it, then I will leave it out, maybe?
No. I was sorry, Nelly, to interrupt. I was just making it visible for the audience. You can continue and pose it to the panelists.
Okay, so then, William, this is for you.
Sorry, could you repeat the question? I didn't catch it.
Yes, sorry. Are we expecting any future demand side related policy measures coming from the Commission anytime in the foreseeable future? Yes, we are now more.
Well, I would say that we're putting the tools in place to make it possible. I mean, I mentioned the potential that you could have if we use the eco-design for sustainable products regulation. As we start addressing particular product groups, if we start looking at minimum recycled content requirements, then of course you're really starting to push the demand, whether it's for plastics, as we heard from Per, or for many other materials. So I think yes, I mean we're certainly putting in place the tools that would help that sort of demand pull.
Thank you very much. I'm actually aware with time we are running late, so unless Bas, you have any important issue you would like to point out now, then maybe we could move to our second session.
I think maybe just to conclude on the point of bringing circularity more also into climate change policies, which I think is one of your main messages. I think that is really badly needed still. Just one example, indeed. In the Commission's proposal for ETS review, incineration was still excluded. And indeed, in the Parliament, we are now discussing and including also incineration into the ETS, so that there the CO2 pricing is going to have an impact there as well. I think these kind of just very simple examples show how much still these two worlds are separate from each other. And indeed, in the current policy review of this entire climate package that is on the table, you can count on that in the Parliament. We will try to give in some hooks and to improve it. But I think one of the bigger challenges is really when the Commission started its Green Deal and putting up the main targets, right? It's not only being climate neutral in 2050, but also being fully circular and zero pollution. Because also that is, of course, very important, because in circularity, we also have to think of zero pollution. Otherwise, we're just propagating pollution too long if we are only looking at circularity. So the targets are there. The proposals are there in different packages, but really making sure that these three targets are being looked at and that the policy packages are also intrinsically addressing all that at the same time. I think that is still the biggest challenge, both for the Commission, but also for legislators in the Parliament and in the member states. And here I really would love to see from Agora some very precise recommendations on how can we do that. And there were already a couple of them in ETS, etc. But I think more of these kind of recommendations would really help also the legislators in bringing these worlds better together so that we can really talk about a climate neutral and fully circular, zero polluted economy. Thank you.
Thank you.
Nelly, if we're on wish lists for Agora's future work, if I could just add very briefly, I think especially as we've been made aware of our particular dependencies from Russia and Belarus recently, it would be interesting to work in the future also on some of the bioresources. And if we look at things like timber and fertilizers and so on, to really look at how that articulation works between the way we use those materials and the energy required and how we can better do that. So I think that we need to look at the bioresources as well as the technical materials in the future. But again, congratulations on a fantastic piece of work.
Thank you, both of you. Thank you. We have a lot to take home, and this is great. Thanks a lot for your very detailed feedback. And now, as I would just like to mention, for all the question and answers, we will take and write to you if we haven't been able to answer those questions on this first session. And then I will, without further ado, I will just hand over to Oliver for our second session. Thank you very much indeed.
Thank you very much, William. Thank you, Bas, and thank you, Nelly, for the interesting discussion. So I have to bring you the second session of our event today, where we will hear from a very interesting panel of industrial actors about these topics as well. So I have the pleasure to I'll introduce now the speakers that you'll hear from. So there'll be Rory Cronin from Unilever. We have Edward Heath-White from Liberty Steel. And if I can ask you also to turn on your cameras, please, so we can see who you are. So Edward Heath-White from Liberty Steel in the UK, Adele Putinelu from Plastic Energy, Roland Scharf-Bergman from Norsk Hydro, and Ku Schenk from Smart Crusher. Thank you, all of you, for joining us today. The topic for this panel is really, we want to hear from industry who are involved in these value chains. What are the main conditions for yourselves to enhance the circularity of your products, to be more efficient in the way you use certain materials, and thereby reduce your CO2 footprint? You've heard already from William Neal about the various policy initiatives that the Commission is developing. So we know that under the Circular Economy Action Plan, there is the legislative proposal for substantiating green claims, and also one on empowering consumers in the green transition. We know that there's the EU strategy for textiles. We know there's the Sustainable Products Initiative and the review of the Eco-Design Directive that William was talking about. There will also be a review of regulations on plastic, on packaging and packaging waste, and an update to EU rules on industrial emissions under the IED. But I'm interested really to hear from each of you, if you could perhaps take 2 to 3 minutes just to give us a short, quick take of what are the main barriers for you, what are the conditions to remove those barriers, and what do you need, or what does your company need from the circular economy legislation from the Green Deal to actually implement these potentials. So maybe I can start with Rory Cronin from Unilever. If you could just take a couple of minutes.
Thanks, Oliver, and thanks, Agora, for the invitation and for the very comprehensive report. I think many of the challenges and opportunities set out we fully recognise and support. So at Unilever, we want to halve our virgin plastic usage in the next 3 years and reach 25% recycled content in our packaging in that same time frame. But to get there, we rely on sourcing non-fossil materials, of which there simply isn't enough. You know, we've talked about supply and demand. I think that's absolutely on the money. And what supply there is comes with a huge on cost, which is limiting. So we believe to unlock circularity, as so well stated in the report, we need an acceleration of both mechanical and chemical recycling technologies and facilities, both of which have lower carbon footprints than virgin production when you look at the full life cycle analysis. So mechanical recycling, we believe, should be prioritised because of the better emission credentials. But as already stated, where mechanical can't be used, chemical should be the option, very much to avoid sending things to landfill or incineration. But to incentivise waste managers and, of course, their financial backers to invest in these facilities, you know, there is a critical role for policy in driving both supply and demand. And just to give you 4 examples in no particular order of prioritisation. I mean, first, the EU, we believe, can address some of the bottlenecks when it comes to approving some of the recycling processes. Second, the Commission can formally recognise chemical recycling, in particular the mass balance approach for including recycled content into packaging. Third, EPR systems are great, but they can be improved, a point also made in the Agora report. You know, this can be done in a few ways, so introducing eco-modulated fees, setting higher recycling targets, and improving source segregating collection standards. You know, as everybody may know or not, you know, the better waste is collected, the higher the quality going into the recycling system, and therefore the higher the yield and the better the chance of improving circularity. And then finally, as alluded to with the PPWD coming up, you know, we fully support the recycled content targets as part of that piece of legislation, and we look forward to working with the Commission if they decide to take that approach. I will pause there, Oliver.
Wow, Rory, excellent. It's a very, very succinct and very, very neat summary. Thank you for also helping us to catch up on some time. I might move on then quickly then to keep the flow going to Edward Heath-White from Liberty Steel in the UK.
Yeah, so hi there. Thanks for inviting me. And yes, great report, and also, you know, the presentation so far have been brilliant. I think the key thing for the European steel industry and its move to low carbon will be the move from integrated steelworks towards DRI, hydrogen DRI, and electric arc furnace. So at the moment in the EU, you've got 2 routes really, blast furnace BOSS and EAF. In the UK, we operate in electric arc furnace. And that makes specialty steel. So actually we do upcycle scrap. So we take scrap and we make steel that's used in aerospace and in very high demanding products. And the way that we work with scrap is that we segregate our scrap. So a scrap merchant will sell us 12 different grades of scrap, but we segregate that into 100 different types of scrap and put it into our value in use model and melt the steel according to the best efficient use of that scrap. So it's possible to do that, but that's only a small part of the European steel industry at the moment. And there's a bigger use of scrap in lower quality products, and also the blast furnace BOSS route uses up to about 25% scrap in its BOSS part. So scrap is used throughout the steel industry, and that will grow in the future. So the key for us really is the supply of well-segregated, high residual scrap, or sorry, low residual scrap without the copper in it. And I think you've got to recognise that it's not just copper. There's also zinc. If it's a boss route, you can't really put zinc into your process. Whereas for an electric arc furnace, if you put zinc-coated scrap in there, you can recover that zinc into the fume dust, and that can go back into the zinc industry. So it's a very complex cycle in terms of steel making and scrap. And I think the key is to get better quality scrap and to also prevent that better quality scrap leaving Europe. So retention of that low residual good scrap within the EU. So that's the first thing, and that's really where policy should be directed. Within the report, it's talked about recycled content quotas, which is quite a contentious issue, I would suggest, within the steel industry, because as I've just stated, a blast furnace boss route can only recycle up to about 25%. And currently that is the biggest route of steel making in the EU. And that will take time to change from that into future technology. And therefore, when we're talking about recycled quotas in products, it depends on what the product as to how much recycled content you can have. So, for example, a car body, the majority of that car body is made out of flat steel, which is blast furnace boss route. So maximum 20% recycled content for that. Whereas the engineered products in it in the drivetrain generally through EAF routes and but also through integrated routes, so you can probably have a higher recycled content. So it's a very complex minefield, should we say. So I think when we're talking about recycled content, we need to be very careful about how we apply that. I think I'll just leave it there for now. Thank you.
Thanks, Ed, for leaving us with the minefield. But very clear points well made. I might then keep us moving, and we'll move on to Adela Putinello from Plastic Energy. Adela, could you introduce your company and what it does, and then also discuss the question?
Yes, thank you very much, Oliver. First of all, thank you for having me. Definitely very, very good discussion here today and very valuable research that has gone into your reports and this event. I work for Plastic Energy, head of policy. Plastic Energy is a technology provider in the space of advanced recycling, chemical recycling of plastics. We have 2 plants at commercial scale operating in Spain for 2 years and different projects around Europe in development. I will start by touching upon 2 things that I believe are very important at the moment. So we tend to think of plastics as a waste and not as resources, and that really needs to change if we need to, if we're serious about transitioning to the circular economy. And then we need to think about the recycling technologies that allow us to get there. So I would say that at the moment, and that has been thoroughly presented by the speakers before me. So there's a lot of plastics that are firstly not collected for recycling. So we're wasting that resource. There's a lot of plastics that go into incineration, and that can be with or without energy recovery. So there's a lot of wasted resources there. And there's a lot of plastic that goes into landfill. And then from the plastics that we do collect, the problem is that a lot of that goes for export. And we have to think about the recycling infrastructure locally, because plastic waste exports are firstly immoral. We cannot send that waste to be recycled in countries where we do not know what happens to it. And then it's a wasted resource. It's a wasted resource for the EU economy. So we need to really reverse that trend, because what happens at the moment is that we are wasting these resources. We're not keeping them in the economy. We're importing plastic products, and we're importing also recycled material. So that trend really needs to be reversed if we're serious about these things. And then secondly, legislation needs to allow us to do these things. So what we would really like to see coming out of the circular economy package and things like the revision of waste framework directive, revision of the packaging waste directive, is that a level playing field needs to be created between the mechanical and the recycling, the mechanical recycling and advanced recycling technologies like chemical recycling for plastics. At the moment, we don't really see that. There needs to be a recognition of the fact that mechanical recycling is very, very well established, and that needs to continue. But chemical recycling needs to work in complementarity with that. And there needs to be a clear understanding of how these work together, because really they do very different things. When you look at the output coming out of mechanical recycling, there's a lot of downcycling happening there. There's a lot of loss of property. We know that we can only mechanical recycle plastics for a limited amount of time. And then if we look at chemical recycling, the output from that is a much higher quality. It allows us to integrate that output into food contact packaging, which is a very, very important area. It's a very problematic area. So chemical recycling is really creating a very, very high quality output. And most importantly, for the benefit of this discussion, and to achieve the goals of the circular economy and climate neutrality, chemical recycling really can decouple virgin production of plastics, because the output is used instead of the naphtha in the production of plastic. So you have a huge opportunity there to realize the goals of the circular economy in conjunction with greenhouse gas mitigation. So we would like to see a policy framework that enables that investment there in chemical recycling to work alongside and to complement mechanical recycling.
Thank you very much, Adela. So you clearly want so as you put it, a level playing field between chemical and mechanical recycling, and the Waste Framework Directive and Packaging Waste Directives to address that concern. We might come back to that in the chat, because I expect this will be controversial for some of our audience. But before we do, I might move on to Roland. Thank you, Adela. And I might move on to Roland Scharf-Bergmann from Norsk Hydro to talk about aluminium.
Thank you, Olga. First of all, let me say some words about Norsk Hydro. We are both an energy and aluminium company, fully integrated from bauxite ores down to aluminium extrusion. And we also operate hydropower plants and supporting wind parks and everything, as well as solar energy. So putting a lot of emphasis on renewables. When it comes to the discussion, there are a couple of things I would like to mention here. First of all, we heard a lot about recycling content, and I think one needs to be aware that recycling content, of course, includes both process scrap generated in manufacturing, as well as end-of-life scrap. And I think what politics are engaging in is to lift the level of end-of-life scrap. And this takes me to my second point, because calculating carbon footprint, I think we need a better differentiation between pre- and post-consumer scrap. Currently, most companies are calculating process or pre-consumer scrap with a carbon footprint of 0, as well as end-of-life scrap with a carbon footprint of 0. And with that, you get a completely different picture, and you don't really support end-of-life scrap recycling. So we as a company, we have started to calculate the process scrap with the original carbon footprint of the metal that has gone into the mill. And simply because there is scrap falling off the mill, it doesn't lose its carbon footprint. And if we differentiate the carbon footprint calculation via this method, we really will encourage a fast growth of recycling rates, meaning end-of-life recycling rates. And by mixing up these scrap types, we get a completely different picture. This is why we as a company calculate this differently. When it comes to process scrap, of course, we also advocate that we need a policy expressing the goal to reduce process scrap, as well as avoiding downcycling of such scrap wherever possible. And when it comes to targeted recycling rates or ratios, especially for aluminium, we need to reflect the lifetime of products and the availability of end-of-life scrap, because aluminium is a very young metal compared to copper, compared to iron and steel. Aluminium is only produced industrially since 120 years. Therefore, this needs to be taken into the equation. Let me also say some words connected to what Bas said earlier. And I think he's quite right that we need a combined policy between as well as the energy sector. And this is exactly what we as a company are addressing in our strategy going forward. So yes, we are addressing energy reduction in our processes and carbon reduction in our processes wherever possible. We are embarking on hydrogen technologies. We are embarking on direct electric melting and things like this. But also we are embarking on a recycling strategy going forward. And this means on an end-of-life recycling strategy. And for aluminium scrap, as well as for some other metal scrap, it is very important to do, like you explained, or one of the speakers explained, that we have a separate collection of certain qualities. And if this is not possible, we need to develop and further develop scrap sorting in a way that we can sort back into the original alloys or even alloy groups. And this is what we are embarking on. We have invested into this, and I think we will soon get there to establish such sorting centers. And in the meantime, what is also part of our strategy, we will bring scrap to our primary production units in order to use the dilution potential that we have there, replacing energy-intensive alloying metal like magnesium, like silicon, with scrap and producing then alloys from this. So I think the combination of such things is very important, like Bas said, and this is what we have embarked on. And we also know that some of our peers in the industry have embarked on similar strategies.
Thank you very much, Roland. Very, very interesting to hear all the things that Norsk Hydro are doing, and indeed the question of new scrap versus post or end of life scrap is indeed quite a topic. Thank you for your introduction, and I might move on now to Koos Schenk from Smart Crusher to talk about recycling and cement.
Good morning.
Koos, can you hear us?
I can hear you, but I only see a very small picture of myself. Is that good?
Yeah, that's fine. I think we can see you.
All right. Now, my name is Koos Schenk from Smart Crusher. Good morning. Before I start the introduction of Smart Crusher, I'd like to introduce you in what is cement and how you make cement. Cement is made from calcium carbonate, limestone, and the cement in its own exists for almost 50% of carbon dioxide, CO2. That's why you bring 2 parts of feed in your cement kiln and only get 1 part out of it. And the other part is pure CO2. So in the end, if you make 1 kilogram of cement, you also have produced 1 kilogram of CO2. Not only from the material, but also from the fuel that you need for that process. What we all see before is that concrete is hardly recycled, only downcycled. And that's why Smart Crusher can make change in it. If you crush concrete traditional, you make from large pieces of concrete, small pieces of concrete. And in the best case, you put some of that concrete aggregate in new concrete, but always with less good effort, because the particle is weaker than traditional aggregates. And so you need more cement, which have a very high carbon footprint. Now, Smart Crusher is another kind of recycle machine bring not concrete from big concrete to small concrete, but liberates all the parts in that concrete. So you get your pebbles, your aggregates, your sand fraction, and your cement fraction undamaged out of it. And if you, so that the aggregates, sand and the aggregates can directly be used in new concrete. But the main core is the cement fraction. If you can bring that back to a cement kiln, you can make new cement without the CO2. And be clear, that is still cement, only hydrated. And if you make new cement out of virgin material, calcium and silicates, you have to bring them together. That costs a lot of energy. Burning out the CO2 of that material takes a lot of energy. If you do it on this way, you bring old cement back as a kiln feed for a cement industry, you can reduce your energy consumption by 60–70%. And in total, you can say the CO2 footprint is also reduced by 80%. And if you take instead of fuel and gas and coal as the fuel for a kiln, you take renewable energy, you can close it up to almost 90%. And for an industry that is 3 times as pollutable as all aircrafts, that can be a very huge change. So we are a young company, and we have proven that the machine works, and we are now scalable. So that's what we do. And for scalable, it's very good that the EU have bring CBAM, because in Europe we produce a minority of our own cement. Majority is from outside inside. We bring it to Europe. So that is very good. And also the ETS, the carbon tax, is for this moment 70 euros. And is increasing, maybe already 90. But you can still buy a ton of cement for around 70 euros. And because cement is 1:1, 1 kilo cement is 1 kilo CO2 almost, you can say you increase that price by doubling it. And it is a big benefit for a cement industry to get use of old cement fractions to keep the prices as well they are now. We all know euros is the best lubricant for the economy. So it is a good thing that CBAM is introduced, including with a rising price for the CO2. And the free tickets has to be lower. Thank you.
Thank you very much, Koos. It's very interesting to hear you talk about ways of actually not recycling just concrete, but potentially also the cement binder in cement, which is, I think, quite a revolutionary idea to many people in the cement industry. We might come back to this question in the chat. Thank you for your presentation. Maybe I think we now have about a little less than 20 minutes for a Q&A with the audience. So I would invite anyone in the audience to write your question in the Q&A, and we can pose it directly to the speakers. I think I have some questions, but I think we already have a couple of questions coming in from the audience. So one question already to Mr. Schaaf-Bergman is, how can we increase access to post-consumer scrap from your perspective? There is little transparency when it comes to the sources of post-consumer scrap. So how can this be done? And perhaps also, Roland, if you could, I also had a question on this point too, which is, some people might argue that it would be difficult to trace and separate what's post-consumer versus what's new scrap. Could you describe a little bit how this might be done?
Yeah, I can try, let's say. So to the first question, I think it starts really with collection, and we have very high collection rates, of course, for some scraps coming from certain certain applications, such as if you look at buildings where we have collection rates of something like 98%. Same goes for cars. Of course, many European cars will see a second life in other regions of the world. They are exported for second and third life. So that's then a more big picture. But if a car is recycled in Europe in a car shredder, then of course the scrap is available, and then this scrap is typically recycled. The problem with this scrap is, of course, that it is a mix of alloys and applications in it. So you have castings, you have profiles, you have sheet, and some other stuff. It's mixed with sometimes other metals as well as with other materials. And therefore, this selective sorting is very important. And this sorting will provide access to valuable raw materials, and it will give us the chance to avoid what we call downcycling. So this is basically the purpose of development that is currently ongoing. And only by improving scrap collection from end of life, we will be able to improve then also the recycling rates. So this is how this can be addressed. When it comes to the tracing of post-consumer scrap, of course, it is difficult if you have a shredded scrap to identify whether this comes from a post-consumer or pre-consumer source. But of course, the material that enters the shredder, there you can exactly see whether this was pre or post-consumer. And this is where I think legislation needs to step in to generate this traceability at the shredder as such. When we, for example, receive, used beverage cans, this is absolutely visible. If you see a bale of can with all other materials inside there, like plastics and so on, different colors of cans because of the brands of the drinks and so on. This is easily identified as post-consumer scrap. The pre-consumer scrap of beverage cans looks completely different.
Okay, so you can tell even with an eye test in some cases.
Yes.
Maybe I could actually bring in Edward here, because I think the steel industry, there's a similar question, right, about how we treat post-consumer versus new scrap. I'm wondering, what's your view on this question?
So, well, my view, particularly with engineering steels, is that pre-consumer scrap can be very important to the process because you know where it's come from and it needs to be separated out correctly. And that's what we do. So we buy pre-consumer scrap because we know where it's come from, what grade of steel it is. And that reduces the amount of alloys that we then have to put into to make the steel again. So the segregation of pre-consumer scrap is very important. So I'll give a good example. So we make cobalt steels. And cobalt steels are very expensive and they use quite a bit of cobalt. If we collect all the cobalt steel scrap pre-consumer, then we can actually use that to melt without using alloys, which is, of course, more efficient. In terms of, I think we do get hung up a bit on pre-consumer, post-consumer. When we get pre-consumer scrap, there's sometimes an assumption that that's waste. It is, but generally, when you're buying a product to make a product, you ensure that you use it in the most efficient way. And therefore, I would suggest that a lot of pre-consumer scrap comes from an efficient process. Yeah. So I think we shouldn't get too hung up about segregating the two out. I think it is important to understand where your scrap comes from. And I think ultimately, really good segregation is what we need, whether it be pre-consumer or post-consumer. So I think Roland was talking about a shredder, and that's commonly used within the scrap industry. You just put the whole car into a shredder, and then you get shredded outcome. Now, there is technology that can segregate that into all the constituent items: plastics, glass, aluminium, copper, zinc, you know, so all the different bits, but that's very expensive. And what tends to happen is they'll shred a car and you'll probably get 3 or 4 streams coming out of it: mixed aluminium, mixed steel, mixed plastic, glass, and materials. So I think when we're talking about scrap and segregation of scrap, we need to get away from just plugging a whole car into a shredder. Yeah. So either have a shredder that is got all the bells and whistles on it and is high technology, or do some pre-removal of items so that you can get the different alloys of aluminium, the different types of steel. So you separate out your drivetrain components from your sheet, for example.
Right. So
that's the important thing for me is the segregation of scrap. Yeah. Whether it be pre-consumer or post-consumer, it needs to be segregated really well.
I mean, it seems. I'm not sure if Roland wanted to react on that. Roland, quickly.
I agree with that. So it will be a combination of, let's say, dismantling parts from goods like cars, as well as then sorting downstream the shredder. And you know, if you look at the picture behind me, this is basically our sorting pilot, where we are doing industrialization of such technology, and we will go live with this technology already next year. So, so with this, we can sort back into the alloys and alloy groups for the element part coming out of the car shredder. And I think this is essential going forward, because you cannot dismantle each piece of a car. That's far too expensive, and therefore there will always be mixed fractions, and those mixed fractions, of course, we need to do something about.
Right. So in a way, when you both agree on the importance of separation and advanced separation technology, the question then really is, in a sense, it's how do you justify it economically, right? It's how do you pay for it, and what are the incentives there that make sure that happens? And I mean, one way might be this distinction between post-consumer scrap and pre-consumer scrap, but one might also be able to think of other ways, which maybe, you know, raises another question maybe to the broader panel, which is, I mean, many of you are working on relatively advanced recycling technologies, right? You know, at the moment, as we presented in our presentation, it seems like there's a lot of money going into virgin material technology, so whether it's hydrogen, you know, DRI or other things. How do you feel about the way in which we support technology in Europe or in your member states, you know, for recycling? You know, is this a gap in the way that we address our industrial innovation policy for net zero? I'm not sure who wants to go. Maybe Adela, do you want to jump in?
Yeah, sure. Thank you. I believe when we talk about plastics, at least, there definitely is a gap. As a technology provider of advanced recycling, chemical recycling of mixed plastics, we operate at commercial scale for 5 years now. But at the same time, we feel that the policy framework is lagging behind. Obviously, mechanical recycling needs to continue. It's a very well-established process, but we also believe that chemical recycling of plastics provides a lot of benefits that mechanical recycling currently cannot provide. So ideally, with legislation, we need to get to a point where this is clear in the policy. There's a clear framework there that recognizes these different benefits that these different technologies can play. And at the moment, there are a lot of gaps there. For example, at the moment, we're not sure how recycled content coming from chemical recycling will be calculated for the purpose of achieving the recycling targets. And that will be done through the Packaging Waste Directive. There's a lot of uncertainty there, and we would like to see a level playing field because we believe, you know, we are operating commercial scale now, and we can offer a lot of good quality recycled content that can go into high specification, food grade, we're talking about closed loop of plastics here in reality. And we can do that. We cannot do that unless the policy framework is not helpful for pushing forward with these investments, for driving, the recycling there. And perhaps to address also a little bit on complementarity of mechanical and chemical. Sometimes I feel like there's a lot of misconception there. Mechanical recycling has a limited cycle of recycling that it can do. It also cannot provide at the moment the necessary recycled content for food grade applications. So for PET, that has worked very well. For other polymers, it is virtually very, very difficult to integrate food grade content into plastics. So to do the closed loop for other polymers outside of PET is very difficult. And that's what we can do with chemical recycling. So that's really important. And really to be able to reach the recycling targets, that part is very, very important. And Plastic Energy has focused specifically on plastic to plastic, so closing the loop. The output from our process is being integrated at production side back into plastics. So what you're seeing really in practice is that you displace virgin production from fossil fuel use, which is extremely beneficial for the purposes of the circular economy and for greenhouse gas mitigation. So we're doing that in practice now, and we would like to see a more, a level playing field for these different technologies to work together to accomplish these goals. And we would like to see that into legislation coming out of these different packages.
I mean, not to mention also that, with plastics, we use quite a lot of naphtha and also natural gas derivatives, right? So if we want to reduce the consumption of those things as well at the moment, I think we might need to put all the stops on plastic recycling. Adela, I'd be keen to bring in Rory here actually, because he's also his company is also working on plastic and to some extent. And Rory, you mentioned in your introduction EPR schemes, so extended producer responsibility schemes, as one of the key policies that are currently put in place by countries in Europe. And you mentioned some ways in which they could potentially be reformed to improve the incentives for enhanced recycling, both mechanical and chemical. Would you like to say a little bit more about that?
Yeah, totally. Happy to. Just to come back on one of the points Adela made in terms of advanced and chemical, absolutely, fully agree with all the points. And there needs to be a mechanism by which we can certify the recycled content that's come through the chemical process, and also to prioritize packaging to packaging through chemical recycling as opposed to waste to fuel. And on EPRs, I think linking to the mechanical recycling point, I think totally right. There are limitations, but over the long term, those limitations can be addressed, we think, through EPR, and that starts through collections and then sorting and putting in place robust targets and standards, because you're only going to unlock the mechanical recycling challenge if, as I said earlier, the waste going into the process in the first place is food grade, to overcome the food grade challenges, and that only comes from proper collection systems, etc. I think eco-modulation fees is an interesting one. We're seeing it in a few markets across the single market, and it's actually a trend that's catching on globally that we see across the world. So absolutely, that will drive behaviours for companies like ours to work with our suppliers to make sure that packaging that goes onto the market in the first place is easily recyclable or easier to recycle. To then, the incentive for us is that our EPR fees will be reduced essentially. So I think that's a really strong mechanism. And then I think the other thing on EPR is I think that the point made in the Agora report there around at what point do you determine whether something's been recycled or not. I think that's incredibly important to shift that to is it actually recycled, and that will inevitably increase EPR fees in the short term, which is something that we're going to have to face up to But I think off the back of that, we will just need insurance through the regulations, etc., that EPR fees are going where they should be going, and that's into the recycling technology.
Okay, thanks. Very clear. I'm very conscious. Thanks, Rory. I'm very conscious that we have not really many minutes left, and there's still one question we didn't answer from an audience participant, which was I think from Michael Poll to Kuz Schenk, about just explaining a little bit more how your technology works to recycle the cement binder, because he's asking, is the hydraulic binding reversed? How does it work? If you could try to answer briefly, if it's not too difficult, just to explain how that aspect of your technology works. Yeah. And then we might wrap up.
Thank you for the question. First, I have to tell that the smart crusher is a low pressure crusher. And if you know that the strength of reacted cement is about 40 megapascal, but the strength of the aggregate is more than 200. So you make concrete out of it of 40, 60, maybe 100 megapascal. So if you crush the concrete between 14 and 100, you only crush the aggregates. You don't crush the aggregates, only the cement paste. So you can liberate the cement clean out of, by sieving and air classifying out of that old concrete. And making cement is a mix. The hardest thing of a cement industry is get the right mix in the cement kiln. About the silicates, the calcium, aluminum, and iron. And you make cement out of it, and you sell it, you make a building out of it. And we, after 40 years, tear that building down and liberated that old cement. But the mix is still the same. So if you heat it up again, you have to react it again by a certain temperature, because you have to bind all the elements back to the calcium silicates you want to have. For in the cement industry, they call C2S hydrate is reacted cement. But if you need unhydrated cement, new cement, is C3S. So you have to bring it back to each other and cool it. But it's only that you can see old cement as pre-baked material. You only have to bring it back in the furnace, but all the components already in it. And cool it down and mill it again, and you have your new cement.
Thanks.
And you save a lot of energy with it. Yeah. And of course, that's why we do it. You save a lot of CO2, because that material already have this output of CO2 the first time. The second time is CO2-free material.
Thanks, Kuz. I hope that was clear to you, Michael. In your
and I can all write, if he Googles on Smart Crusher, he found the website, and it's more theoretical, because I'm afraid to go too deep, but otherwise people do this. Time out.
Yeah. No, I'm going to have to stop. I'm going to have to stop you there, because otherwise we'll spend the next half an hour talking about the details of cement chemistry, and it wasn't quite the idea. So thank you to Ed, to Rory, to Adela, to Roland, and to Kuz for the very interesting interventions and for participating in our panel. What I take away from this discussion is a number of points regarding the critical importance of separate collection and of the way we actually collect this waste in the first place, of separation, of maintaining pure streams of waste. The issue of exports and the supply of these materials is obviously critical to recyclers. The question of the economics of investment into these new key technologies is also a critical issue. And but it's exciting to hear that there are these many potential technologies and ways of doing things that are out there. I would note William Neal from DG Environment in the chat noted also during our discussion that the forthcoming review of the End-of-Life Vehicles Directive, which is scheduled for early next year, and the Directive of Type Approval of Motor Vehicles, with regard to, will treat the questions of their reusability, recyclability, and recoverability. And so these should in principle be relevant to some of the discussions we were having around shredding and steel and aluminium and so on. So it's important perhaps that we have that one on our radar in terms of policy. I might thank all of our panelists once again, and now hand back to Matthias Buch for his closing remarks. to finalize the webinar.
Thank you, Oli, and thanks to everyone sharing their time and their expertise. I think what my main takeaway from listening to the presentations, to the comments on the presentations and to the exchange is the first one really we're at just the right time to bring the focus of the circular economy discourse together with what's happening on energy intensive industries in Europe. So far, the whole circular economy debate has been focusing not on the energy intensive, so on steel, cement, plastics, but rather on other types of value chains. And given the urgency of the climate crisis, but also now to rapidly reduce our fossil fuel dependency, these two discourses really need to be brought together. And the circular economy action plan and all the piece of legislation coming out over the next few months really are the opportunity to link up those two types of thinking. One important message I heard is really that we need to be very serious about creating the robust demand for high quality, closed loop recycling and material efficient climate neutral products. So this needs to be worked into the legislation coming forward. I heard from Bas Eickhout that there might also be some thinking on how to link up the circular economy debate to some of what is in the Fit for 55 legislative package, i.e. the using of ETS innovation fund to also support the transition, the greater uptake of circular economy there. Potentially also the proposal on the energy efficiency for buildings directive, where there could be some thinking on embedded carbon in buildings as the broader effort to make buildings more efficient from a climate perspective. So I think we will need to come back to those points. What I also took from the very rich debate is that then, of course, if you are going to the specific value chains, so steel, cement, plastics, the challenges at technical level, the incentives needed to enhance circularity, and also then reading over to the regulatory side are not surprisingly different when it comes to the detail. But my really, biggest takeaway really is that now is the time to link up those two discourses on circularity with the energy intensive industries, value chains, and because of the urgency to lift those potentials to reduce emissions and to also reduce our fossil fuel dependency. This being said, many thanks to everyone that has been participating in this webinar. Many thanks to all those listening in, taking your time. The webinar, the recording will be made available online soon. All the related materials presented here as well. And so big thanks to all the panelists, to all the colleagues from Agora in making this happen, in helping us to have a very, very rich and I believe informative morning on mobilizing the circular economy for energy intensive materials. So I don't know, Nicola, I hand over to you to close the webinar, no?
You've almost said everything that I was going to say. Maybe we can just make all panelists switch on the camera again to see who was there. Thank you very much to everyone being actively involved on the panel, also to the audience who kept putting questions in the Q&A box. We will take a look at them. I'm not sure if we are going to be able to answer all of them So please excuse that, but we will certainly take them into consideration. And if there's anything you urgently need to know, you can always contact either the colleagues directly or just send an email to webinar@agora-energiewende.de, which Robin has also posted into the chat. And then I will forward it to the according or respective colleague to make sure that you get your answer. Unlike I said at the beginning, actually executive summary and full study are now online. Our graphic department was a lot quicker than expected, probably even by themselves. So you find both now on the website, and Robin has been kind enough to put the links into the chat. And if you'd like to be kept up to date on our upcoming events, then register for our newsletter if you're not already receiving it. We will be at the Berlin Energy Transition Dialogue next week, Friday, with 3 webinars in a row, one at 9, one at 10, one at 11 Central European Summertime. There's also one on industry, global steel at a crossroads is what we call it. So check our website or register for the newsletter in order to be kept up to date. And I have a small marketing question for the one in the audience who are still there, and Robin is probably going to share it in a minute. Other than that, have a good rest of the day and stay healthy and keep safe. Bye-bye.